a little bit different from the type of questions that you do. So try to just get a grasp of it. And initially you will get some questions like prove that root 2 and root 3 are irrational type. So let's go by this chapter. And chapter's name is real numbers. In our next class is a physics class. The next class we will be doing again coordinate geometry. I asked you to do the NCERT problems. So we'll revisit coordinate geometry on that day. And this class, after this algebra will be over. So we will just move on to surface area and volumes. Once we do that, then we'll do triangles and circles all in one go. Okay? So come, real numbers. The first thing that we study in this chapter is called the fundamental theorem of arithmetic. No need to actually memorize it, although just try to understand what it means. Before understanding fundamental theorem of arithmetic, you should be familiar with what do you mean by prime numbers. Prime numbers are numbers which are only divisible by itself or by 1, right? What are composite numbers? Any number composite. Let's call about a composite cake. What is a composite cake? A chocolate and a vanilla cake will be called a composite cake. Wherever you have two fragments contributing to one, so composite wall, it will be half brick and half concrete. Composite number means some prime numbers are inserted inside it. Just वैसे ही सोचो. So the fundamental theorem of arithmetic says, just understand, don't memorize, that given any composite number, you can factorize it, and this factorization will give you all prime numbers. Whether I factorize or you factorize, our factorization will be unique. What might differ is the order in which we present it. Please understand, what might differ is the order in which we present it. Let's take a number 6. If I factorize 6, I should get a 2 and 3. That means even if you factorize 6, you will also get 2 and 3. We can't get anything different from 2 and 3. But the difference is, while I may show 6 as 3 into 2, you can also show 6 as 2 into 3. So what do we mean? Any composite number can be factorized into its constituent primes, and this factorization is unique. What differs might be the presentation or the order in which the factors appear. Now put on your English hat and try to put it like a theorem. Every composite number can be factorized into its prime, and this factorization is unique. What might differ be the order in which the prime factors are presented to you. Is everyone familiar with this? Understood? Is there any? So let's say I take a composite number which is, say, 28 is a composite number, and I try to prime factorize it. Children, whenever you are doing prime factorization, though you have learned it from grade 8, you will factorize only with prime numbers, starting with the smallest. Now 2 is a unique prime number, which is the only even prime number. Otherwise all prime numbers are odd. Okay, na? So let's start to do it with 2. So I get a 14 out here. Then 2 gives me a 7. And then 7 ones are 7. That means 28 is a composite number whose factorization will give you primes which are 2 and 7, where 2 is appearing twice and 7 1. And this is unique. Somebody may write it as 7 into 2 into 2. Somebody may write 2 into 7 into 2. Somebody may write 2 into 2 into 7. That is allowed. But this is unique. Is this understood? Once we end this discussion on composite numbers, our next discussion hovers around those class 6 topics of LCM versus HCF. Okay. Now I know all of you know how to do LCM and HCF. If you do LCM, there is one method of doing LCM in which we do it by the tabular way, right? So let's say, like in your book, they have numbers like 6 and 20. This is the way we have learned from our childhood. So we'll take numbers 2, 3, 6 to 10, 20, right? After that, we do not see any common numbers, common factors out here. So as the word says LCM, you multiply it also in the format of an L, right? And this will be giving you your LCM. Let us try and understand what is the meaning of, what do you understand by LCM actually, right? If you look at the LCM of these numbers, then what is the LCM? 2 into 10, 20, 20 into 3 is 60. So 60 is LCM, means lowest common multiple. So let us take, let's say you take 6 out here and you take 20, right? These are the two numbers, and 6 is building on its multiple and 20 is also building on its multiple. So multiples of 6 can be obtained by 6 into 1, 6 into 2, right? 6 into 3. What is the LCM coming out here? 2 3s are 6. So okay. And blah 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 blah. Since you got the LCM as how much? 60, right? So I multiply this with 10. If I multiply with this with 10, I get a 60, right? 6 into 1 will give me 6, 6 into 2, 12, 6, 3, 18. That means if 60 is the LCM, 60 is the lowest common multiple of both. 60 will be a multiple which will be for 20 also, as well as for 6 also, and it is a common multiple, lowest common multiple. So if I go by 20, 20 into 1, 20, 20 into 2, 40, and 20 into 3, if I apply 20 into 3, that also gives me 60. So 60 is a common multiple, which means if you would have taken, say, if you would have done it with 6 and 6, then also you would have got a common multiple, but that is not the lowest common multiple. The meaning of lowest common multiple is, given three numbers, where do they merge for the first time together? Change it into a question now. Rita, Sita, Nita cycle together in a park. It is very common when you do morning walk or something, you will keep on finding that same person again meeting. Now, if three of them will meet when it's the lowest common multiple of all three of them. Have you understood? Now, let us see how to find out LCM by prime factorization method. So we were trying to do the LCM of 6 and we were trying to do the LCM of 20. We'll see for both. एक बार सिखा देंगे, एकदम सीख जाओगे. LCM, HCF also will do by 2-3 methods. So let's do the LCM. We do the prime factorization. What is prime factorization of 6? You'll do 2 into 3. 2 has appeared once, 3 had appears once. Agreed? If you do the prime factorization of 20, 20 is 2 into 10, which is 2 into 2 into 5. So I'll say 2, and 2 is appearing twice, into 5 into 5. Right? This is what you are getting. My what you call advisory to you people will be, whatever factors you get. Now here we got the factors 2 and 5. What is missing? The prime number 3 is missing. 3 is out here, and this went till 5. 5 is missing for it. Fill for everyone whatever is missing. Can I write 3 into 0? Can I write 5 into 0? All okay? Now what are you doing? LCM. L stands for lowest, but your brain should think like Bakul. Whatever you ask not to do, you will do that. So your brain is thinking now what? Lowest. So you will pick up the highest powers. Okay. So let's see the LCM now. Is 2 present in both? First make the factors present in both. 2 is present in both. What is the highest factor of 2 square? In 3 the highest is 3 to the power 1, and in 5 the highest is 5 to the power 1. 5 3s are 15, 15 4s are 60 is your LCM. So the way you do it is factorize one, factorize the other, and then fill up whatever is in between them, like 2, 3, 5, 7, 9. Ultimately you are doing prime factorization. You should get prime. And if you see the HCF, HCF means highest. Think like Bakul, lowest. So in HCF what you will do, you will pick up the lowest exponent. So in 2 square and 2 to the power 1 is 2 to the power 1. Between 3 0 and 3 1, 3 0. And between 5 0 and 5 1, 5 0. So 2 is your HCF. समझ में आया? Whenever they ask you to do it in this manner, this is the easiest way, so that in exam you will never forget. Whenever you do LCM, take the highest powers. Whenever you do HCF, take the lowest powers and fill up the missing one. ऐसे बताया था आपको या स्कूल में just 2 to 2 square 2 ये वाला टेक्निक सिखाया कि नहीं? सब बढ़ लो करके. Any school has thought? Are you all are done or not, Shreya, in your school?
Yeah, we did.
Did you do this technique, like fill up the remaining ones also to find LCM? That's the best and easiest way, and take the smallest one. Now let's see some more things about HCF. Okay, let's say we have numbers like 8 and say 16, not 16. 16 will not give. मजेदार नहीं होगा. 8 and say 28. Okay, we are supposed to find out the HCF. What does HCF means? HCF means highest common factor. Imagine 8 is one drum and 12 is also, what is the other number after 28 is also, I have taken one drum. Find a mug with which if I try to empty, both will get emptied at this, completely emptied. What size mug should you take? So a common factor, highest common factor, which will try to empty out equal amount of substances from both. Are you getting it? Equal amount from both the sides. So let's take the HCF of these two by our class 6 method. So what will you do? 2 4s are 8, 2 14. Then 2 2s are 4, 2 7s are 14. Doesn't go any further. This is your HCF. In HCF, you don't multiply in the L pattern. A very nice way of doing HCF is called the GCD method. Greatest common divisor. Has this been taught in any school? This is most interesting. Greatest common divisor. And this is actually what we used to do as Euclid's division lemma. But this is interesting. Take 28 and try to divide by 8. 8 2s are 16. 8 3s are 24. 8 3s are 24. How much is the remainder? 4. Take 4 as the divisor and now divide 8. Right. Then what do we get? 4 2s are 8. The last divisor is called the HCF. Greatest common divisor. Last divisor. 4. This is very helpful in bigger numbers. Like say somebody tells you 62 and 236. Yes.
I didn't understand.
Well, you will understand in the next one. Don't worry. Take the bigger number and try 62 and 236. We are supposed to find what? HCF. Right? So what we will do? Take 236 and divide it by 62. Can you do for me? Just take it as 60. 63s are 180. 64s are 24. 16 to 4 is already crossing over. So 16 to 3. So 3 2s are 6. 3 6 are 18. So with 3 if we do, 3 2s are 6. 3 6 are 18. Hey Anurag, itna samajh mein aaya ki nahi? Have you understood this? Right. What is the remainder now? 5 is the remainder? No, 50 will be the remainder. 50 is the remainder. Agreed? Now 50 will become your divisor and you will try to do 62 becomes your dividend. Shall we? So it will go with how many times? 51s are 50. 12. 12. With 12 you will now try to divide 50. So 12 4s are 48. Now you have 2 and with 2 you will try to divide 12. 2 6 are 12. You have to get this 0. This is your HCF. The last lone divisor is your HCF. ये helpful होता है. अच्छा अब सोचो, if they tell you instead of 2 numbers for 3 numbers to find the HCF, so you just take the middle number and do it with the smallest number. You will get an HCF. Now between that number and the remaining third you try to do, then also you will get your HCF. Anyone who has not understood this technique? So let's take one more easy example. Okay, let's take an easy example. Let's take 8, 18 and 26. Let's try to do HCF. 2 4s are 8, 2 9s are 18 and 13. Okay. What is the HCF? 2. Let's do it with our technique now. Or in these things, the tabular method is a faster method. 18 को 2 से करो बेटा. 2. So sorry, 8 से करो. 8 2s are 16. Then you have a 2. With 2 you try to do 8. 2 4s are 8. That means between 18 and 8 the HCF is 2. Now you do between 2 and 26. 13, 26. So 2 is the HCF. क्या उतरे साहब समझ में आया? Sure though? So horses for courses. If you are getting numbers like this in your grade 10, you are not supposed to use that this wala system. You're supposed to do it with prime factorization. Got it? And prime factorization becomes easy as long as the numbers are smaller. If the numbers increase, you can do by a GCD method also. Have you understood the GCD method? The last divisor is always the HCF. Here we also get another what you call identity, that if you take the LCM of any two numbers A and B and you multiply it with the HCF of the two numbers A and B, then what you get is the product of A into B. We'll do some board oriented problems, so should not be any issue. Product of A and B. A composite में तो और कुछ नहीं है. If you get problems like burfis are to be stacked, children are to be made in the form of a marching army, it's always HCF. HCF means what? Highest common factor. My burfi, kaju burfi and kalakan should look at the same height, but I have got X pieces of kaju burfi, Y pieces of kalakan. So the highest common stacking that you can do. But knowledge itself tells you what type of problem it will be. Traffic light, again synchronizing back. LCM, lowest common multiple. Meeta, Sita, Geeta meeting LCM. तो ये भी ठीक है. ठीक है. इसके बाद the next is the irrationalities. Right? If no issues, okay. Let's visit now numbers. अच्छा numbers visit करते हैं. आ जाओ. What is this number? Pi. Pi rational है कि irrational है? अच्छा. और ये क्या है?
Closest rational definition.
It's an estimate of what pi.
22 by 7 is rational or irrational?
Rational.
But then why is it said to be pi? Pi. So what is an irrational number? So numbers. So what is a rational number first of all? What is a national number? A number in the form of P by Q, where P and Q are integers and Q does not equal to 0, is known as a rational number. Huh? You said terminating.
No, he said in the form of P by Q.
P by Q खाली बोलने से नहीं होगा ना. P is what? Parminder and Q is what? Queen. A number in the form of P by Q. Now you all are grown up children. P and Q belong to the integer family. Q not equal to 0. This is rational number. है ना? P by Q. So that's 0. I can grant you full marks if you are in grade 6 or your one yellow star is there on the board, right? We need to take it off now. It's okay. P by Q is a rational number if the number is in the form of P by Q, where P and Q belong to integer family, right? Thank you. All of you said very nicely. So many people have this what do you call the concept that pi is equal to 22 by 7. Pi is not equal to. In fact, if you become a teacher and you give some problems, then you should always say take pi as 22 by 7. 22 by 7 is the closest representation of pi, which he said very nicely. And the first thing comes up is, since pi is an irrational number, 22 by 7, is 22 an integer? Yes. Is 7 an integer? Yes. Is 7 equal to 0? No. So this is a rational number. How can a rational number be equal to? Vakul cannot be equal to a hardworking boy, right? This is not possible. So a rational number cannot be equal to a irrational number, right? So my question now arises, what is an irrational number? What is an irrational numbers? So let's see like this, okay? Let's take a concept like this. You have a P by Q. It's a rational number. A rational number can be terminating or it can be non-terminating. Non-terminating. So let's say we take a number which is something like, say, a 2 upon 8. A 2 upon 8 will terminate. Okay, a 2 upon 8 will terminate. 8 2s are 16, 8 5s are 40. But if I take a number which is a 3 upon 10, a 3 upon 10 does not terminate. If this does not terminate, then it will go on a repeating mode. And the numbers which repeat are called the period of that number. In grade 9 used to do show 0.23 bar as a rational number. Used to say, no, let x be equal to 0.23, multiplying both sides by 100. So it becomes a non-terminating repeating, and say in this question it will be 0.3333. So you can put 3 dots, or you can also put whatever is repeating, on that you put the bar. That is called the period of the decimal. The periodicity is at 3 is the period of it. Have we understood this? Right. However, if you get decimals which are non-terminating and non-repeating, then you have learnt like a to parrot that it is called irrational numbers, which you are correct. But how do you bring the definition from the family or the clan? We had integers. From integers, we developed this species, which was called rational number. The rational number species, finally, we have two type of DNAs, terminating and non-terminating. If it is non-terminating, it is always repeating. You just can't pick out a property like this and tell that it is irrational. Irrationals, one of the properties is this. But can you build up the DNA of irrational? Can you give a try? I'm saying, how did the irrational numbers form up? Now, try and understand once again. We had real numbers. Real numbers are having what? Better natural numbers, whole numbers. And then, can you give me a difference where you tell me a number which is a real number but not a natural number? Can you give a number? Can you give me a number, an example? ये क्लियर करो पहले क्लियर होना बहुत जरूरी है. Do you know what are natural numbers? Naturally counting numbers are called natural numbers. 1, 2, 3, 4. You can't go to a mango tree and say, can you see the 0 mango? There's nothing called 0 mango. 0 is India's gift to the world. Does a tree give you 2 by 3 mangoes? No. The tree gives you counts which are in integral. 1 mango, 2 mango, 3, positive integral. So naturally counting numbers are called natural numbers. With this natural number, if you put a whole, that is which looks like a 0, then it is called whole numbers. So whole numbers will be 0 and then the entire series of natural numbers, right? Fine. Now these natural numbers one day had a competition, as I always say, like Snow White and the 7 dwarfs, mirror, mirror on the wall, who is the prettiest of all? So all the natural numbers stood in a queue, 1, 2, 3, 4, 5, 6, up to positive infinity. Agreed? And they said, darling 0, why don't you be our mirror? And we start looking at each other. So it's number 1, -2, -3, dot, 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 to negative infinity. When you're going to grade 11 next year, then this will haunt you a lot. This is represented as -R2 plus R. This is the real numbers family. So does a 2.5 come as a real number? Yes. Does a 0.5 negative come as a real number? Yes. Does 2 come as a real number? 2 is an integer. So 2 is a natural number. So 2 is a whole number. So 2 by 1 is a rational number. Right? Does a 0.33 bar come here? Yes. And suppose I have a number which is 2.382614938496, as per your definition, something which is non-terminating and which is non-repeating, you call it an irrational number. So is it also present here? Yes. So you now become the Santa Claus and you say, "Sab kuch leke aise aoge." You're carrying the real numbers sack on your head. Right? So you've got an idea of real numbers. So in grade 11, you'll open up a box called imaginary numbers. Imaginary numbers, okay? And they will be represented on a different plane called the Argand plane, where you'll get a number like root of -2. Root of -2, right? And the root of -2 doesn't exist as per you. So we'll get a number I is called iota, where I square's value will be equal to -1. I square is equal to -1. And this starts opening up your imaginary numbers. Like this number will be represented as 2i. I square is -1. So what is I? Root of -1. This is 2 root of -1. So this will be shown as 2i. Root 2i rather, not 2i, root 2i. And then in grade 11, you'll get a number which will be something like 5 plus 4i. This is a complex number. It has a real part and it has the imaginary part also. Imaginary will be dealt with imaginary, real with real. This is what is waiting for you. So my question again comes, and I go back to my previous slide, that you developed rational numbers and you very nicely said terminating, non-terminating, repeating, and then you said so nicely, how can you take a property and define? I want the DNA definition of irrational numbers, right? You have done it in grade 9, but the only thing is that you have forgotten. Irrational numbers are the square root of non-perfect squares, out of which one subset is all the prime numbers. All prime numbers are non-perfect square. Any non-perfect square you take up, 11. Is 11 a prime number? Yes. Okay. Is 33 a prime number? No. Is 33 a non-perfect square? Yes. Do the root of 33. If you have the calculator right in front of you, it will be an irrational number which will be non-terminating, non-repeating. So you can write it down. Irrational numbers are square roots of non-perfect squares. Non-perfect squares. And one of the family inside it will be the prime number. समझ में आ रहा है तो बेटा? घर में जाके करके देखना. Pick up any number. 35. Is it prime? No, sir. Is it non-perfect square? Yes. The root of 35 will always be irrational. Clear? So don't just say irrational numbers are non-terminating and non-repeating, which is one of the features of the number, but the number's actual definition, which clan do you belong to? Khandan kya hai aapka? So my khandan is all the non-perfect squares root, right? And then we have to prove in this chapter called proof of irrationality. A number will be given to us and we have to prove that this number is irrational, and that is done by method of contradiction. Before that, we have to also understand one thing. Like say, for example, if a number divides square of a number, then the number divides that number also. What I mean to say is that if 5 divides square of a number this, then 5 should also divide 5. If P divides A square, P will also divide A. And this actually we can prove again. Let the factors of A square be P1, P2, P3, or A be P1, P2, P3. And since you say that P divides, so P will be one of them. This is necessary. So please write that down because it will be necessary. If P divides A square, then P divides A. A few knowledge about from grade 9. Let's revisit. Okay. A rat multiplied by a rat. What should be the answer? A rational with a rational will always be a rational number. There is no doubt in this. Okay. It will be a rat. A erat multiplied by a erat. This will be what? It can be may or may not be. For example, a root 2 multiplied by root 2 will give you a rat. But a root 2 multiplied by a root 6 will give, root 3 will give you a root 6, which is again erat. Clear? How about additions? Rat plus rat. Rat plus rat will always be rat. Rat plus erat. Erat is a virus. Rational plus irrational is always irrational. So sometimes if somebody gives you something like 5 plus minus root 3 without looking at it, this is rat, this is erat. So you can straight away say that this number is irrational. ठीक है ना? अब हमें करना क्या है? Prove that root 2 is irrational. Okay? So our proof is prove that root 2 is, now this is there in grade 9 itself. Root 2 is irrational. Something they are saying, prove that Vakul is lazy. So we will prove it by method of contradiction. We will first say, let us assume Vakul is not lazy. And we will go with our problem. And then suddenly we'll find that he is sleeping even at afternoon after pouring water. This contradicts our assumption that Vakul is not lazy. Hence, our assumption was wrong. Vakul is lazy, proved. So we have to prove that Vakul is lazy. So what will be, this is called method of contradiction. So we assume what the first step will be, let us assume a root 2 is rational. Now see children, my job is not to do this problem. I know all of you are super mugging, what do you say, parrots, and you can mug up this problem and answer it. I'm only saying, if any of your hard disk, that slot does not work at that time and you're not getting that step, so how to get it? So we have said that let this be rational. If you are rational, so step number one becomes, this is a thought process. If you are rational, you should be representable in the form of P by Q, right? This is the indicator, the thought process. So based on our assumption, we say let root 2 be equal to some R by S, where R and S are two integers. लिख सकते हैं ना? If let us assume Vakul is punctual, hardworking, so we are writing Vakul is equal to getting up early in the morning, doing yoga, meditation. We can write that, no issues. Now R by S may not be in the smallest form, right? So our next step will be to actually think R by S in the smallest form of something like B by A or A by B, whatever it is. So we say that R by S has some common factor. Let that common factor be H. This is something like now in 25 by 5 format. So we say that let there be some common factor H or some common factor which, after nullifying out or cancelling out from the numerator and denominator, we are now left with root 2 is equal to, say, A by B or B by A, whatever you want. Okay, whatever you want. Now what is A by B? A by B is the smallest form. A by B, and now you can't write smallest form. You will write such that A and B are co-prime. They are co-prime, and whenever you introduce the word co-prime, it means they cannot have any more factors in common other than 1. That is, no common factor other than 1. No common factor other than 1. Understood? So how did we start? Contradictory statement we have made, our assumption, this is rational. If it is rational, याद रखने का, exam में नहीं भूलेंगे हम, then it can be shown as an R by S, and here you can write R and S belong to the integer family, S not equal to 0. And then we say R by S has been reduced to its lowest term A by B. Now where A by B is our co-prime numbers, do not have any common factors other than 1. इतना तो लिख ही सकते हैं, ठीक है? Now what do? We do square both sides. Square both sides, then you get 2 is equal to A square by B square. 2 is equal to A square by B square. Can you then write A square is equal to 2B square? A square is equal to 2B square. A very interesting observation. No need to mug up anything. You can think it like this. A square is equal to 2 into B square. Can we not think like this? That means when A square was expanded in its factors, 2 and B square are factors of A square. इतना तो समझ में आ गया. This is coming from where? The fundamental theorem of arithmetic. Every composite number can be factorized into its primes. So that means 2 is a factor of A square. So 2 divides A square, right? From here we can say 2 is a factor of A square. So 2 divides A square. So 2 also divides A, which we just took. If 2 divides A square, 2 should divide A also. यहीं पे बच्चे भूल जाते हैं एग्जाम में जाके. So we will square both sides and we will get a 2 is equal to A square by B square. So we can write A square is equal to 2 into B square. That means the factorization of A square reveals 2 as one of the factor. That means 2 divides a square. And if 2 divides a square, 2 should divide a. So we say, let a divided by 2 be some number which is c. A is divisible by 2. So a is equal to what, beta? 2c. So what is a square equal to? 4c square. कितना लिख सकते हैं? Correct? Now, punch this value out here. Let's punch this value out here. Then what happens? 2 is equal to 4c square divided by b square. Agreed? This 2 cancels this 2. 2 2s are 4. So we get b square is equal to 2 into c square. Just see the statement. Have you understood? I have said that 2 divides a. So when 2 divided a, we got a number c. So a is equal to 2c. So a square is equal to 4c square. And I input that in this statement. So I get 2 is equal to 4c square by b square. 2 and 4 cancel. So I finally get again b square is equal to 2 into c square. Now again think from the perspective of fundamental theorem of arithmetic. When b square was factorized, 2 came out as a factor. Right? So I can write 2 is a factor of b square. So 2 divides b square. So 2 divides b. Hi. 2 divides a also. Yeah, Bakul, we sprayed water on Bakul. Still, we sprayed water. Then we itched his foot below. He's sleeping. So 2 divides b. 2 divides a. That means a and b have a common divisor which is 2, or a common factor which is 2, which is against this statement, because in this statement you said a and b is the last reduced to lowest term co-primes and they should not have a common factor other than 1. That means our assumption that Bakul is a hardworking boy was wrong. It is proved that Bakul is lazy. So our assumption that root 2 is irrational is wrong. Anna Bakul? So root 2 is irrational. How will you proceed from here? You will write 2 divides b. So you give this as one statement, some a, and 2 divides a. You give this as statement a and you say that this is statement b. My job is to make you understand the chronology so that you don't rectify it. From a and b, it is observed that small a and small b have 2 as a common factor, which contradicts our initial assumption that a and b are co-prime. Hence, our initial assumption that root 2 is rational is wrong. And so root 2 should be irrational. अब एक बार आंख बंद कर लेते हैं और पूरी कहानी को फिर से देखते हैं. Prove that root 2 is irrational. Sir, root 2 is rational. If root 2 is rational, it is equal to some k by l, where k and l are integers. Then k, l and l has been reduced to their lowest terms as some a by b, where a and b are co-prime. They have no other common factors other than 1. So we write that root 2 is equal to a by b. Squaring both sides, 2 is equal to a square by b square. Then you get a square is equal to 2 into b square. That means in the expansion of a square, 2 is a factor. So 2 divides a square. That means 2 divides a. That means 2 is a factor of a. Statement X, close. Then we take, since a is divisible by 2, let a by 2 be equal to c. So a is equal to 2c. Squaring both sides, a square is equal to 4c square. याद हो गया मेरे को. Put 4c square. A square is equal to 4c square. And now put the value of 4c square in that original. So original is what? 2 is equal to a square by b square. So you'll write 2 is equal to 4c square by b square. 2 and 4 cancel each other. Finally, you will get b square is equal to 2 into c square. That means C2 is a factor in the expansion of b square. 2 divides b square. That means 2 divides b. 2 is a factor of B. A statement Q. From P and Q statement, it is observed that 2 is a common factor for both A and B, which is against our initial assumption or our conclusion where we had taken A and B to be co-prime. Hence, our initial assumption that root 2 is rational is wrong. So if they ask you to do for root 3, can you do? If they ask you to do for root 5, can you do? Yes. Problem becomes interesting when they tell, let's just say, prove that 3 plus root 2. Now 3 plus root 2 is what, beta? Rat plus irrat. That means this has to be irrat. Prove that this is irrational. So we will say what? This is, we will say, let us assume that this is rational. ये क्या खुचर पुचर करते रहते हो यार? 1 घंटा बैठ नहीं सकते. What great secrets you all have. Even lovers don't talk like this. In our engineering college, we used to see. You ate? What did you eat today? अच्छा, you went and woke up. सारा दिन चिपके रहते हैं. You know, like those gladiator type movies will be there, na? The queen will be in love with some gladiator. रात को ऐसे करके, I've always missed you. I have been in my dreams ever, always. वो ऐसे करके दोनों चपर करते रहते हैं. मेरे रसल क्रो, प्लीज ध्यान दो क्लास में. ठीक है? Let this be rational. So if this is rational, then it's what? 3 plus root 2 can be written as something like, what do you say? R by S. Can we say it like this? Some R by S. This is rational, so R by S. Second step, what do I write? I would write 3 plus root 2 brought into lowest terms is something like A by B. Agreed? Then our next step is 3 minus A by B is equal to negative root 2. Can I write this or not? यहीं पे आपका problem fail हो गया. 3 is a rational number. A by B is a rational number. So your LHS is rational. How can your rational LHS be equal to irrational RHS? So your initial assumption. Yeah, it's much more easier. So your initial assumption is wrong. But there can be some teachers who in your pre-board will tell you, first you show me that root 2 is irrational, then you give me this statement. So you should see how much marks is it carrying. If it carries 5 marks, first prove root 2 is irrational. Irrational. Whatever is the number, minus or plus, it doesn't matter. Prove that as irrational and then go by this. And if it is just 2 marks, you can go by this. Horses for courses. Understood? Okay, very nice. Let's see a number which is P upon Q. Now this is totally different from this, okay? P upon Q. Is P upon Q a rational number? Yes. Now the question is, how do you know whether it will terminate or not? Now this is interesting. If you can express Q as m into n, 2 to the power m into 5 to the power n, where m and n are integers, positive, where m and n are positive integers, then this one will terminate. Will terminate. The question arises, sir, there is a problem which is something like, say, 6 upon 8. 6 upon 8. Will 6 upon 8 terminate or not? So initially we will say we may do it into some short note. But this one allows us. You should be able to write 8. 8 can be written as 2 to the power 3, 5 to the power 0. This will terminate. However, if I tell you 6 by 13, will this terminate? This will not terminate. Because 13 को तुम कैसे भी ऐसे नहीं लिख सकते हो. ये भी एक ट्रिक जान के रखिए, हेल्प करता है. Whether a number will terminate or not, take the denominator and try to express the denominator like this. You may tell me, sir 5 तो है ही नहीं. जैसे एक नंबर है आपके पास, something like say 3 by 5 बोल दिया, क्या ये टर्मिनेट करेगा? आप बोलेगा सर मैं 5 में 2 कहां से पैदा करूं? अरे 2 to the power 0 तो ला सकता है. So this will terminate. ये टर्मिनेट कर जाएगा. लेकिन if this number was 3 by 7, अब नहीं करेगा. 7 you cannot show as 2 to the power m into 5 to the power n. Is this understood? Okay. Our next question. One thing that comes up in the chapter, show that 4 to the power n will not have a factor which will end in 0. Now, no, you need not memorize it. Prime factorize this. Ultimately, what am I getting? I get a 2 square to the power n, which is a 2 to the power 2n. Imagine that this 2n is some number 8, 10, 20. That means what? 4 to the power n, when you prime factorize, you are getting what? 2 into 2 into 2 into 2 into 2 into 2. How many number of 2's? 2n number of 2's. Do you ever see a 5 out here? No, if you don't see a 5 out here, there won't be a 0 ending factor at all. If you want to get a 0 ending factor, like say 40, 20, 30, you should have a 5. 5 multiplied by 2 will give you 10. 5 तो रहना ही पड़ेगा. So your target should be, क्या मैं इस नंबर में, अब मेन एग्जाम में चेंज कर दिया, बोला 6 to the power n, show that you can never have a 0 ending factor. You can have no 0 ending factor. So what do? I can write it as 2 into 3 to the power n. So it's a 2 to the power n into 3 to the power n. That means in his prime factorization, I will get lots of 2's. I will get lots of 3's. But one thing which I will not get is, I've been missing you 5 since the time you left me. Right? Again, why are you looking at him? Every time I say like that, he looks at him. Okay. So you change your school. Either you change your bonded isotopes. So we can write 2 to the power n into 3 to the power n does not have any 5 as any of the factor. Therefore, no expansion, no value of n will actually have the expansion of this with a multiple ending in, or the factor ending in 0. This chapter does not have anything more than that. If you feel I have left out something, I don't think I have left out anything. बस यही है. For your pre-boards, if you want to score your pre-boards, please rectify the irrationality proof and be rest assured that ma'am will give you not root 2, root 3. 5 minus root 2 is irrational in 5 marks category. I believe no child should leave it. In that, please first prove root 2 is rational, then prove 5 minus root 2 is rational. But if the question is of 2 marks category, you can do it. Did you understand how to do LCM? Write all the factors. Don't write the factors you got. Write all the factors, prime factors, till you end. What I'm saying, say suppose there was a number x and excess factors came as 2 square, and after that you got a 7. So please also fill up 3 to the power 0, 5 to the power 0. This you please do. Acha. And I had something like a y had only a 3 square. Then please make it 2 to the power 0, 5 to the power 0, 7 to the power 0, so that they are fine. Then take the call. LCM means lowest, take the highest power. HCF means highest, take the lowest powers. Did you understand the GCD method? Last divisor is always you, and it will match. Sir, agar match nahi kiya to karega hi karega. That is Euclid's division lemma. It has to match. And at one stage, you will find the last divisor. The last divisor is always the HCF. Got it? So what we will do, our next class is on what date, beta? Friday. Not Friday. We have our next class is on Friday. Yeah, Friday. So Friday we have a physics class as usual, and you asked me to do magnetism. Not magnetism. We will be devoting 2 classes of physics now in numericals. So please understand what I'm going to do. Friday we are getting into numericals of physics. Come Monday, coordinate revisit for problems. Come Wednesday, physics numericals revisit. Physics numericals revisit. Physics end. And next Friday, we get into magnetism. Right? And then on Monday, we will open up surface area. And surface area, when we open up, I'll not like to open up another chapter because we have got enough time. We'll do surface area slowly. We'll finish surface area. then areas related to circle, then we will come to this. And if you think you can handle surface area and areas related to circle together, I think you should be able to handle. Otherwise, it will be like 3 chapters. School में भी कुछ एक पढ़ा रहा होगा. So I just don't want to tax you. We'll do only surface areas and volumes. Okay? So 5 minutes early break. If you want to discuss any